In this video, I am going to show how to simulate basic logic gates using Proteus simulation environment. It's a very easy to use tool for the purpose. So let's get started. This is the main Proteus schematic capture window. In order to simulate logic gates, we first need to know the IC identifier or name for that gate. So an IC or integrated circuit is a collection of basic electronic devices that work together to perform the functionality of a logic gate. Let's say we want to simulate a two-input NAND gate that is basically the negation of an AND gate. We can go onto the internet and just search with the keywords two-input NAND gate IC, and we can get the IC number. And for two-input NAND gate, we usually come across something like 74HC00 or 74LS00. Now this video is not about the numbering of the ICs and the nomenclature that is used. Uh, the next video in this series that is totally focused on the ICs, their naming conventions, and also the technologies that they are built on. Right now, the focus is that we want to use the Proteus for simulation of basic logic gates. So instead of knowing the IC names corresponding to each logic gate, we would try to explore the ICs that are available in the Proteus library. For that, we can go to place and then components by right clicking in anywhere in the main window, and then we look for the gates in this library. We are going to restrict ourselves to two input logic gates only in this video. So let's scan through the libraries and look for keywords two input. So, but this is the main library, and you can see it has a lot of components, not only ICs but other electronic components as well. So where should in the library we look at? We need to know a little bit about the ICs and their families. In this video, let's just say we want to use the ICs that belong to TTL family, and more specifically we want to use the TTL 74LS family. Again, more details about TTL and 74LS, it is going to come in the next video. So let's select the TTL 74LS series and try to look for any gates which says two input. So we look at the description and we have 74LS00 to start with. We find it's a two input NAND gate, and we can also see the symbol over here. We click OK, and then we have this logic gate to be placed anywhere on our schematic sheet. A schematic is basically a circuit diagram where the inputs and outputs are usually labeled with some numbers. So with this NAND gate selected on our cursor, we can just click anywhere to place an instant of this gate like this. Let's go to the library again and place other two input gates we can find. We can also search for the gate, and we can see a lot of gates from a lot of families listed here, and we can select any one of them according to our requirements. So these are all the TTL families, transistor logic. More about these families in the next video. Let's find two input gates. Here we find a two input NOR gate, which is basically negation of a two input OR gate. And if I double click this, it appears in the list of devices over here. It's not placed on the schematic yet, but it is added to the list of, you can say, the components we want to use in our schematic. And once in this list, we can select a component at any time, and we don't need to bring it every time from the pick components window. Let's keep on adding other gates. We have AND, OR, XOR. Another thing you notice in this PCB review window, you can see how physically the IC looks like. Alright, let's zoom in so we can better see our gates. In this little window at upper left, you can navigate through the schematic sheet and focus on a specific area within. You can see the IC name 74LS00 and two inputs labeled 1 and 2 and one output pin labeled 3. We will discuss more about these pin numbers in the next video. For now, let's try to give some inputs to the gate and observe the output. For digital inputs, we have logic state, and for observing digital outputs, we have logic probe. They are available in large and small sizes. Let's choose the large size for logic probe. Another thing we have for input is logic toggle. Let's add this as well. Now let's place the logic states and logic probe for outputs. While placing the wires, you can click along any path as you desired. Otherwise, the software would try to kind of do the auto routing, which does get annoying a lot of times. Now let's place all other gates. It gets a while get used to the environment, and you can use the zoom options to adjust the view. After placing the logic probes, we can use this run button to simulate our logic gate. Let's look at each of them one by one. Uh, at let's look at the OR gate to begin with. We give the input. Another thing, while you are giving the inputs, it is always advised that you give the inputs in the order. So we have two inputs, like in this case, we have to give them in the order 0, 0, 0, 1, 1, 0, and 1, 1. Now, if we observe the output, both the inputs are 0, then the output is 0, and if at least one of the input is 1, the output is 1. Similarly, for the AND gate, we follow the same pattern of giving the inputs, and for the output of an AND gate to be 1, both the inputs have to be 1. For an XOR gate, the output is 1 only if both the inputs are different. If both are same, like both are 0 or both are 1, then the output is 0. For NOR gate, the output is opposite of OR gate, and you can observe that for the output of NOR gate to be 1, both the inputs have to be 0. You can see the functioning of OR and NOR and compare them. Similarly, for NAND gate, the output is opposite of an AND gate, and for the output of NAND gate to be 1, at least one of the inputs has to be 0. So if one of the input is 0, the output of the AND gate would be 0, and correspondingly the output of the NAND gate would be 1. Download the Proteus file from the link in the video. Just play with it and get familiar with the Proteus environment. In the next video, I'm going to talk about the ICs and some of the things that we left in this video, like IC names, pin numbering, data sheets, and we will come back to this schematic and try to understand it more with the help of data sheets. See you in the next video. Bye.